In this video, I'm going to be discussing how to solve systems of equations using elimination. Now, in my previous video, I talked about how to use substitution to solve a system of linear equations. Now we're going to talk about elimination. Now, first of all, you need to know that elimination is useful when both equations are written in standard form. So, for example, here, both of these equations are written in standard form. Now, using substitution would be a huge pain because I don't have x or y by itself, and if I were to get x or y by itself in either equation, it would take a lot of work. I would end up with funny fractions, and so substitution is definitely not the way to go when you have equations in standard form. This is why we have elimination. Now, the goal of elimination is to rewrite both equations so that one variable has opposite coefficients. So in the example I have here, y, the coefficient of y is 5 in this one, and negative 5 here. This is a prime example of when to use elimination because my coefficients are opposite, meaning one is positive, one is negative. So let's go through the steps of how to solve this system. So the first thing we're going to do is we're going to pick a variable to eliminate. Now in this system, it's really obvious that we are going to eliminate y because the coefficients of y both are opposite. So one is 5, one is negative 5. Now step 2 is kind of unnecessary, and I'm going to skip it for right now, but I'll come back to it. Now step 3 is add the equations. Now you may not know this, but it is possible to add two equations. It's called linear combination. That is the fancy term for adding two equations together. So here's how it works. What I'm going to do is I'm going to make sure my variables, my like terms, are all lined up, and I'm going to add. So here I do 2x plus 6x, and I get 8x. 5y plus negative 5y gives us plus 0y equals 17 plus negative 9, which is 8. Now, if you notice here, I have a 0y, and it is unnecessary for me to write the 0 here because it doesn't change anything. That's called the additive identity. So all I have to do is write 8x equals 8. Therefore, I have eliminated the y. It is gone. That's where this gets its name from, elimination. Now to finish solving, all I have to do is divide both sides by 8, and I get x equals 1. That was step 4. Step 5 is to substitute the solution to find the other coordinate. Now just like in substitution, we need to have both an x and a y in order to have a solution. So what I'm going to do is I'm going to choose either the top or the bottom equation and replace the x with 1. So I'm going to use the top equation, so I'll use the blue. So this will be 2 times 1 plus 5y equals 17. So I get 2 plus 5y equals 17, and I just solve this. So subtract 2 from both sides, so 5y equals 15. Divide both sides by 5, and I get y is 3. Therefore, my solution is the point 1, 3. Let's take a look at another example of elimination. So in this example, I'm going to start by picking a variable to eliminate. Now, if I'm looking at both of these equations, I don't have opposites. 3 and 5 are not opposites. Negative 3 and 6 are not opposites. So this is where I'm going to have to think a little bit about step 1 and 2. Now, step 2 says multiply one or both equations so there are opposite coefficients. Now, just like before, I can do something a little different here. It is possible for me to multiply a whole equation by a number. That's perfectly fine. So long as I do it on both sides of the equals, I preserve equality. So what I'm going to do here is I'm going to eliminate the y's. And here's why. If I look here, I have 3 and 6. I know that I can multiply 3 to get 6 easily. And I see here 1 is negative, 1 is positive. So all I'm going to do here is I'm going to multiply this entire equation by 2. And I'll show you why here in just a second. So when I do that, I get the values. Let's see, that would be 10x multiplying everything here by 2. So 2, 2, 2, So 10x minus 6y equals negative 22. And I'm going to go ahead and rewrite my red equation. Plus 6y equals 48. Now, in doing that, by multiplying everything by 2, if you notice now, here I have a negative 6, here I have a positive 6. So I'm going to go ahead and use linear combination again, add these two equations, and here's what I get. I get 13x plus 0y, negative 6 plus 6 is 0, equals, that would be 26. Negative 22 plus 48. Now again, I see here I have 0y, so it's no longer necessary for me to write the y. Then I go ahead, divide both sides by 13, so x equals 2. So there's my x-coordinate, and the procedure is the same as everything else. I need to find the y that goes with it. I'll go ahead and use the red equation, because it doesn't matter. So I do 3 times 2 plus 6y equals 48. And I go ahead and solve this. So that would be 6 plus 6y equals 48. Subtract 6, so that would be 6y equals 42. Divide y equals 7. So my solution here is the point 27. So that is just a brief tutorial on how to use elimination to solve systems of equations.